Now what happens when we've got a b value other than 1? That means our period is going to change, which means our asymptotes and our zeros are going to change from the original parent function. So let's look at that. Right here I've got y equals the tangent of 3x. That means that for every pi units, because originally tangent had a period of pi, there are going to be 3 full cycles. So every pi units, there are 3 full cycles. So if we look at original tangent, y is equal to the tangent of x. My original graph had an asymptote at positive pi over 2 and at negative pi over 2. I had the 0 go through the origin, and then I had this rise and falling pattern for tangent. That was my original. And right here, we had a distance of pi units. Now what I've got to do is for tangent of 3x, I've got to fit 3 full cycles in there. So I've got to divide that into 3 equal parts. So now, y equals tangent of 3x is going to look something like this. If over here is my pi over 2, over here is my negative pi over 2, I've got to fit 3 of these tangents within that same pi units. 3 times as many. So we want to look at this, we want to analyze how long is the new period. Remember that period for tangent is going to be pi over b, which in this case is pi over 3. So each one of these segments here is going to have a pi over 3. And that makes sense because if I originally had pi units here and then I'm dividing it into 3 equal parts, that means each piece here has to be a pi over 3. Where are the new asymptotes? And then where are the new 0 values? Well, just as we did in the previous section with sine and cosine, and we looked at our characteristics and found distances in between, we can do the exact same thing here with the tangent graph. We know that our original tangent graph had values at pi over 2 and negative pi over 2. So the way we can find a new asymptote is take my equation here, which is going to be 3x, and I set it equal to my original asymptote. And I'll do the same thing with the other asymptote that I know. 3x equals pi over 2, 3x equals negative pi over 2. And if I divide both sides by 3, I'm going to see that x is going to be pi over 6 and x will be negative pi over 6. So right here, I'm going to have one asymptote at pi over 6, and this asymptote is going to be at negative pi over 6. The other piece then are, what are the 0 values? Well, this one we can solve pretty easily because we know that the first 0 is at 0. And if I'm going over a period of pi over 3, that means each of these have to be pi over 3 over. So the 0 values are going to be 0, pi over 3, and negative pi over 3. Now, if you couldn't figure that out by looking at the graph, you can solve it algebraically. And the way you would do that is you take your new tangent function, which would be 3x, and you set it equal to the original 0, which here was 0. Divide both sides by 3, and you get x equals pi over 3. If you look at your original tangent function again, over here, this was 0 pi. That means the next 0 value would be at regular pi. So that means if my new function, I'm going to take 3x and I'll set that equal to pi, divide both sides by 3, x equals pi over 3 for the new one. So you can either do it graphically or you can do it algebraically by setting your new trig function equal to the characteristic of your old trig function, or the parent function.